Hello, Saraya, or sorry, hello, person on the internet. Someone asked me about finding critical values for confidence intervals in statistics and asked for a video recommendation, but I don't watch enough internet. So here we go. I'm just going to show you how this works. I'm going to share, you know what? I'm going to make a little thing I can draw on. I'll draw a picture for you. I'm going to share a very boring screen, but it'll get less boring as we go. Look at that. There's my dang Google Drive. Okay, hold on. I'm going to go to the world of math 244 where we work. You can skip forward a few seconds to the good stuff if you want to. I'm going to make us a place where I can draw stuff. 244 spring. That's us. Notes. Can draw in here. Let's draw. Okay. Critical numbers. If you want to find a critical number for a confidence interval, here's what I do. First, let's say we pick a confidence level. Critical. It's not the fanciest video, I know. Critical number Z star 4. I'm going to go for a special fun number. How about 98% confidence, because it's not a common one. Okay, what I do is I want to know in the world of a normal distribution, this is supposed to be a pretty well-drawn bell curve. It's as well as I can draw it that fast with my mouse. I want to have in the middle of here. So that's a normal distribution right there. Let me label it. A normal distribution with mean 0, standard deviation 1. That's the shorthand from lots of stats books. And you can now see that my 98% confidence, that amount is in the center here. So I'm shading the center of this probability curve. 98% of it. Yeah, buy it, buy it. Artistically, does it look artistic? I hope so. Heck, I'll even label that with my pen. That's 98% in the middle. And this critical number, Z star, it's going to be the number that we want to find. This one, wait. This number, Z star, that is this upper boundary of that picture. Now, in olden times, people would go look in books, in tables in the backs of books to find this. Nowadays, we can use a computer. I'm going to use the program GeoGebra. So it's already open, luckily, in another window in my browser. It's not an important text. All right. So here we go. GeoGebra Classic. I'm cruising into probability where that normal curve lives. There you go. And notice, oh, hey, you know, if you have not messed with GeoGebra before, I recommend messing with it. It's a great program for lots of stats calculations, both using distributions and doing calculations for confidence intervals and hypothesis tests. It's whatever method you use. If you do by hand stuff, have at least one tech method you can use to check your work or to do it quickly when you need to. But here, you'll notice when it has a picture like this shaded in the middle, it's going from -1. Let me do a little, if this is new to you, I want to do some highlighting here so you can see what I'm talking about. Oops. It's from -1 on this scale. So that's the X scale is this axis here, the X axis, up to +1. It's telling us that the area in between those two, like that blue shaded zone, is a little more than 68%. Okay. Now in our picture back in our slide that we were drawing and working on before, you'll notice that I want 98% in the middle and I want the upper border. Now, good old GeoGebra does not let us, doesn't let me switch this 68+% just straight to 98%. I have to just look at like one tail of the distribution. So in old-fashioned textbooks, you had to look at the lower tail. So that was a little The tables and books, it's a little more complicated, but here I can enter any percentage I like of area, and it'll find me the border for it. Now, looking back at our slide, we can see, let me shade this in blue here, because that's like GeoGebra. Up here, oops, that's not my little favorite crayon. Up here, that's the upper tail, is the cutoff. And in that little upper tail, you can see right in this little area, because this is a symmetric curve with 98% in the middle, I've got to just have 2% remaining in both the little tails, both of them, and in each single tail, just 1% of the area, like that. See that? So there's also 1% down here, and they all add up together to 100% of the area under this probability curve. Yeah. The nice thing is in GeoGebra, I can plug this 1% right in to the machine and get my calculation done. So here you go. Let's look at it. Remember the area here, you type that into this zone. So right there, I'm going to type my 1%. Hey, cool. And the second I've typed that, you can see right here is the cutoff. You can see it on the graph. Oops, I like green because I did green before. Right there's the cutoff number, and rounded to 4 decimal places, that's our critical number, 2.3263. Kind of cool. Let me go, let me make this screen a nicer size for a picture. Oops, that's a bad size for a picture. That's bad. I've almost got it. Hold on. There you can see all of those notes. Let me redraw those little notes. We entered this number, 1%, and we got back our critical number. That number there is this 2.3263. I'm going to grab a screen capture of that, because then once I've captured this little buddy, I can also dump it into our other slot, other picture that we have here. So back here, paste, there's our little screen capture. See that? So that's what we did. And we have our critical number. Oops. So Z star equals, what was that? 2.3263 for 98% confidence. Not the best video in the history of videos, but it is a video. I hope that helps. Have a good one.